Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to take up the next acid derivatives in the series of carboxylic acid derivatives that includes esters. So if you have not checked the previous video of this particular series that I am uploading every day, I request you to kindly go through it, check it wisely and then switch to this particular part of the series. Okay, so let's just see what are the topics that we are going to cover in this particular video. Okay, so the topics to be covered includes the nomenclature of esters, correct, and the preparation and physical properties. So in the first video, I'll be discussing these three topics, and in the next video, we will be taking up the chemical properties in detail. Okay, so before jumping to the nomenclature, let's just talk about what are your esters all about. This is the general structure of your ester, that is RCOOR, and these R and R dash, it could be similar alkyl group or aryl group, or these both could be different as well. That is one thing. And esters, they are actually the most important class of your acid derivatives that we can see. And whenever you do your functional group detection in lab, you identify your esters via fruity smell. Whenever you are going to obtain fruity smell in your respective test in the lab, you are going to you are going to say that these are esters present over here. Okay, so its characteristic feature is the presence of fruity smell, correct? And they are the most important class of acid derivatives that we are going to take up today. So proceeding with the first topic, that is nomenclature of esters. See, esters are named by writing the name of alkyl or aryl group of the OR dash part of your molecule. If we write it like this, RCOOR dash. Okay, so what they are saying, writing the name of alkyl or aryl group of this OR R dash group of the molecule before the common or IUPAC name of the parent acid with its terminal IC acid replaced by 8. So you are going to replace the terminal IC acid with 8. Okay, this is the main rule you should keep in mind wherever you are naming your esters, correct? So that is one thing, and these are the general formula that I have already discussed. And over here you can see this particular part is your alkenoid, and this is over here is your alkyl group that you are going to name first. Okay, so this is your first structure of ester, and the common name would be going to be this particular part you are going to name first, that is methyl, and the rest of the part you are going to name it as for replacing IC acid with 8. Understanding, that is your common name, and IUPAC name would be methyl methanoate. Likewise, you are going to name rest of the structures as well, correct? So proceeding further. Okay, so you can see in this particular topic only that these are the other structures of your esters that you can see. First one being methyl methanoate, okay, and another one is your methyl ethanoate. Another one is your ethyl methanoate. Okay, so this is how you can name your esters over here. That is one thing. So proceeding further to the method of preparation of esters. See, we are going to discuss 4 methods in detail. First one is by action of alcohol on carboxylic acid. Second one is your alcoholysis of acid chloride. Third one being the reaction of acid with the diazomethane. And fourth one is your by Tishenko reactions. Okay, so let's take up all these reactions in detail one by one. So the very first reaction being the acid by the action of alcohol on carboxylic acid, that includes your direct esterification, which we have discussed in detail in your carboxylic acid chapter as well. So if you have not gone through that particular video, I'll mention the link in the description box. Just go through it, check it wisely, and otherwise I am going to discuss over here also. So yeah, let's see. Over here you can see in the reaction, your carboxylic acid is reacting with alcohol in the presence of acid, and it results in the formation of this ester over here with the release of water as well. So the key bond that is formed is COR, and the bond broken would be COH. Understanding? So that is one thing what is happening. Your esters, they are generally prepared by heating this carboxylic acid with alcohol in the presence of few drops of concentrated H2SO4 or a direct HCl gas, and this process is your direct esterification. So this is going to be the mechanism of esterification, where you can see your carboxylic acid is first getting protonated, and after getting protonated, this protonated carboxylic acid, what will happen? This oxygen, this will be carrying your positive charge. This oxygen, being electronegative in nature, will be taking up the electrons from this pi bond over here and making this carbon susceptible to get attacked by your nucleophile alcohol. Correct? And now it leads to the formation of this particular tetrahedral intermediate that you can see, in which there is occurring proton transfer, like that. You can see proton transfer is occurring, which leads to the structure this. Okay, and what is happening now? Now next step there is occurring elimination of your water molecule, which leads to the formation of this protonated ester. Correct? Water molecule will get protonated, water molecule will get removed from this particular structure, this very structure, and it leads to the formation of this protonated ester. Alright, then in the last step, what is occurring? Deprotonation, you can see, and it leads to the formation of your ester, like that. So this is the mechanism of your esterification. Proceeding further to the second step, that is your alcoholysis of acid chloride or acid anhydride. See, what is occurring in the next step is your esters, they can be easily prepared by the action of alcohol on your acid chlorides or anhydride. This you can see over here. This is your acid chloride on reaction with your alcohol. It leads to the formation of ester, as you can see, with the release of HCl as the side product. So that is one thing over here. Correct? So let's see the example related to the same. You can see the example where you will react your benzoyl chloride with ethyl alcohol, that is CH3CH2OH, and it leads to the formation of your ethyl benzoate, C6H5COO CH2CH3. Okay, so this part, alkyl group, you are going to keep it in the front. So it would be ethyl, then benzoate. Okay, like that you do the naming. Okay, and side product released would be your acetic acid. In this case it is going to be HCl only. Correct? So that is one thing. That is how you have seen how your acid chloride react with your alcohol, and it leads to the formation of your ester. You can also see the reaction of your acid anhydride, where you can react your acetic anhydride like this, CH3COOCCH3, like that. Okay, and it will react with again your ethyl alcohol, CH3CH2OH. It leads to the formation of ethyl acetate, that is CH3COOCH2CH3. Correct? That is your ethyl acetate plus CH3COOH is released as a side product when we are using acid anhydride. Correct? And this is how your alcoholysis of your acid chloride and acid anhydride occurs. So proceeding to the third part, that is your alcoholysis of acid chloride or acid, it is your second part only. Here we are going to discuss the mechanism, and this is a reaction of your acid anhydride only. Here you can see the mechanism, how it is occurring. So your oxygen is accepting a pair of electron from this particular pi bond, making this carbon susceptible to get attacked by your nucleophile alcohol. So there is occurring nucleophilic addition, like that. That is first step. Now in the next step, what is occurring? Your this particular structure would be will be getting deprotonated. How this is occurring? Because this pyridine, which is acting as a base, will be extracting the proton from this particular structure, and it leads to the formation of this particular structure, that is this one. Okay, now what is happening? There is occurring the expulsion of your carboxylate anion. That is your third step. After the expulsion of your carboxylate ion, what is occurring? There is occurring formation of your ester with the release of your carboxylate anion as well as this pyridine base as well. Okay, and yeah, that's all about it. So in the first step, what is occurring? Nucleophilic addition. In second step is occurring your proton transfer. In the third step is happening your expulsion of carboxylate ion, which leads to the formation of this particular ester. Okay, so that is all about this particular step. Now let's just discuss about the third preparation method, that is by the reaction of your acid with diazomethane. Correct? What is happening? Your methyl esters, they can be easily prepared by treatment of your acid like this with an ethereal solution of diazomethane. Okay, you can see over here with the ethereal solution of your diazomethane, it leads to the formation of this particular ester over here, and nitrogen gas is released as well. Okay, so in the next slide you can see how this particular reaction occurs. See, this is your structure of your acid. Okay, and what is happening in this particular acid, you can see diazomethane is protonated first of all, and after getting protonated, what is happening, this negative ion, negative charge on your carbon, it will act as a nucleophile. It will extract this particular proton over here, and it will after abstraction of this particular proton, it will get protonated by the carboxylic acid, forming your carboxylate anion. And this carboxylate anion formed, now what is happening, it will further attack the methyl only, and it will ultimately displace your nitrogen like that. So this is one step, this is one method how your mechanism occur in this particular case of your diazomethane. And you can take the reference from your book as well, that is your reference book, whatever book you are following. This mechanism is also given in the book of Pradeep's as well as modern very well. So proceeding further, okay, this is another method of preparation, that is by Tishenko reaction, where your acetaldehyde, or you can say aldehyde containing alpha hydrogen atom, they on treatment with aluminium ethoxide like that, they will undergo condensation and will be producing esters. Okay, so this is one method how it is occurring, and I can show you how this reaction proceeds. So you can see the two molecules of acetaldehyde like this, and okay, let me write it down for you. Alright, this is how it is done. Now what is happening, you can see, okay, and this, there will be occurring condensation. Okay, and this in the presence of your aluminium ethoxide only, it leads to the formation of this particular structure, that is ethyl acetate. So that is how this reaction is going to proceed. Correct. So that one is your Tishenko reaction. Most of the time directly this question could be asked in your paper, in your subjective paper. This naming reaction could be asked directly. So you should keep that in mind. Now, okay, now let's just discuss about physical properties of esters. So in the physical, there are three properties that we are going to discuss, that include physical state, boiling point, solubility. So in the physical state, you can see esters of the lower carboxylic acid, they are colorless and are pleasant smelling liquids, while those of higher acid are colorless, odorless solids. So what I mentioned, esters of lower carboxylic acid, they are going to be colorless, pleasant smelling liquid, while those of higher acid are colorless, odorless solid. Okay, and the next point would be your boiling point, which include the boiling point of ester is lower as that of So I'll stop my video over here only, and in the next part we'll be discussing the chemical properties of your esters, and I request you to go through all the links that I've mentioned in the description box so as to get a better understanding of this particular chapter. So yeah, that's all about it. Do subscribe my channel and do press the bell icon for more updates. Thank you.